Let's remove the muffler. Then we're going to remove the carburetor. And then we're going to get some timing numbers. The carb looks pretty clean, actually. It doesn't look like I'm going to need to do too much to it. Now I know that this is a Strato engine rather than the typical, the pre-2010 engines are non-Strato. They have different chambers and whatnot inside of them. So this is a bit of a different animal to modify. But we'll play with it just the same. Of note, the boot clamp is fully cinched down here. It is tight down there. So I'll have to keep a note of that for when I reassemble it, that it does have to be cinched down completely in order for it to be tight. I had an air leak on the 385 XP because I did not cinch that down all the way. Let's do 2 3mm Allens here. These are very gentle type screws, so you do have to be careful. 1, 2. And let's remove the choke here. Carb comes straight up and out. This I'm going to put in a special spot because I actually don't want to mess with this at all. This does have limiters on it. It's the same exact as the 385 XP. If you want to move the carb settings beyond the limiters, you actually have to press the ring in and then move the screw. But that's the way to do that. The limiters are there to make sure you don't go beyond in measurement. Carburetor here is a Walbro. I see a 216 RWJ, and I see a 216, and there's a couple other letters here I have a hard time reading. I don't see any other markings on it. Something about a 216. Now this piece comes off to the front, I think. Yep. It's on a rubber mount. The rubber mount stays here. And this piece pulls off to the front again. And then the choke lever out that way. I'm going to put these back together so we don't lose them. I'm willing to bet in order to get proper timing numbers, I'm going to have to uncinch the clamp here and remove this plate as well, so we can move the whole thing out. Before I do that, this is the 3mm Allen, only useful for carb bolts really. There's an Allen on the side here for this air scoop. That just tends to be a really easy part to lose. Let's undo the 4 bolts holding this plate on. You can move the carb out of the way. The boot out of the way, sorry. Short bolts. plate's loose. Let's undo the clamp here. Good old-fashioned WD-40 in here. Let's remove the clamp entirely. Don't know even if I can, but yes, I can. Gonna put this back together. Back together. It's pretty bendy. Let's get the impulse line out of the way. This does not look like a line that really has much to do with fuel, so it may not need to be replaced. Separate from that piece first, then rotate it out. Yeah. I get a suspicion that this is a pricey part, so probably don't really want to mess it up. But I do want to clean it really well. Eventually. Now, the Strato engine, which I'm not super familiar with. In fact, this is the first time I've seen it. Nice and clean in there. Okay. So we'll look at that and see what we can get for timing numbers. Now we remove the exhaust. Removing the exhaust, 4 bolts here. Kind of short. Really short, in fact. Four bolts for the exhaust, the holder bracket anyway. Now I believe these are bigger. I think they're 5mm. Big heavy bolts, 5mm head. Kind of a rough, rusty muffler. Rusty mufflers aren't that big of a deal. This I might paint. Not too much damage, a couple of dings, dents. This is a little dented up top here. We'll open that up a bit just for fun. Exhaust gasket looks okay. While I'm ordering things, I might want to order a new one, because if I don't, what are the odds? it'll break, and then it'll be the one thing I'm waiting for to start the saw. So what do we got here for... You got about 1 millimeter or 2 all the way around to do the port matching. So the bottom's pretty tight. Widen it a bit though. So now we can look in at the exhaust here, which is way high up there. Turn the flywheel around. I don't see too much scoring, so that's good. Looks nice. So at least the motor seems to be alright, which should be for a 2012 model, even if it's used a lot. For a 2012 model, the motor should be pretty nice. Which is probably the one saving grace of this saw, but still means that we got a whole pile of work. Let's take the flywheel off, we'll put the timing wheel on it, and see where we're at. We're going to get the flywheel off. Spark plug out. That's a fairly new plug. Let's do the nut here. Flywheel nut comes off, but now I need to get a hammer. So I'm going to put the nut back on, gentle like, and we're going to, because I don't want to really hit that with a hammer. I want to hit the nut preferably rather than hitting the crank itself. So now I need a hammer. Throw a little WD in here. Oh, you know what I was using? So I've got my Wonder Bar there. Just lift up, really. Still not loose. Obviously, the proper way to do this is with a puller. One day I'll make one. Right now I don't have it. So there's a washer here and the nut. Don't want to lose those. This flywheel, I think I'm going to change out. Oh, let's see if it's the same flywheel as the 385. It doesn't have the same number on the back. EM original. 537-0516, 537-0516. They are, I believe, the same for all intents and purposes. Got to make sure the timing's the same, though. Sure looks like it. Alright, so I'm going to use this is a 385 XP flywheel. In the place of this one, because this one's all messed up, and I'm going to retain this one just so I have an idea of what stock timing is. So now I've got the degree wheel out. I'm going to put the degree wheel on, and this is for sure a makeshift degree wheel. Now we got to figure out top dead center. which I showed in my other video. This is literally a die holder, and I'm using it as a piston stop, and the piston stop ends up in a fairly arbitrary location. So I've got it in there, it stops right now. We need to make a mark. We need to make a mark on the cylinder. Now you can do this with a coat hanger or something and have it actually sit here on the degree wheel, but not going to do that for this particular saw. So I make sure the degree wheel is fairly tight against the crank. Now I've got a piston stop, which I'm using a die holder. It just happens to be something I can stick in here at an arbitrary distance and hold it so it doesn't move. This bangs up against the stop, and the degree wheel is set at a particular spot there. So let's move it to 60. So we go back and forth. Actually, I need to move this forward quite a bit. So now we're about, okay, so now it's about 30. I'm going to tighten this down a tad. Let's go around the other side. And that is 64. So 30 to 64 is 34. So 64 minus 17. 64 minus 17, half of 34 is 47. So we're going to put it on the 47 mark. And then we're going to go back. Pretty darn close. That's 40, I would call that 45, 46-ish. So I need to go, that's 45, 46-ish. Let's go about 46. Let's aim for 46. I'm going to tighten this down a tad more, because this actually cinches the degree wheel down to the nut that's holding it against the crank. This is my makeshift design. Feel free to critique. That's 46, that side. That's 46, that side, which means we should be good around top dead center. So we're going to show this right here. So that's 46 there. We're going to, it stops right there at 46. Here's my mark. We're going to go back around the other way. Stops at 46 there roughly. Let's go back around this way to double check. 46. By eye, close enough. Alright, so let's, if you really want to get nutty, let's put it like, there's 8. Let's call that 19. So now I should be able to go around, and this should hit it roughly 19 as well. Looks like 19 to me. So then and therefore we bring it to TDC, and we should have piston at top dead center. That's how I do top dead center. So now we look for timings. Exhaust timing. And I'm just going to get these numbers. You can look at my 350 video, have a little bit more detail, but there's way more detail in other videos on how to get numbers like this. Exhaust timing is 100, so it's 90, 95, 100, I would call that 101, maybe 102. Let's call it 102. Exhaust timing is 102. Transfers. Frankly, it's so incredibly dark in there, I can't even see it. There it is. So, 90, 100, 90, 100, 110, 115, 16, 17. Does that sound right? 102, 117, and the intake timing. Almost looks like the intake is inverted. Instead of having a slight dome shape to it, it's got a, instead of being concave, it's convex. Don't know if you can see that, but alright, so intake timing is 72. 72. So there's our stock numbers. I don't know much what to do with this engine, so I'm going to go online and talk to the guys and see what everybody says to do with this motor. I'm excited to play around with it for sure, but I don't know exactly what to do with it. So, there you have it for the night. I'll continue the dismantling process another day, and we'll see you then. So let's continue by taking this apart even more. Now I just got an offer, actually, to swap out this piston and cylinder. There is certainly some controversy surrounding this motor. So I'm going to consider actually swapping this out. Somebody can use this as a stock motor. That's not a, absolutely not a problem. It seems to run fine. But apparently there's some controversy as to whether or not porting this is actually a good idea. And since I want to play with things a little bit, might be better to have a non-strato motor. Non-strato being no ports here. So this is just a different style of motor, and there's some significant controversy surrounding it. So apparently if you leave it stock, it's brilliant, but I'm gonna play with things a little bit, and I think, and we'll see where we go from there. One thing I did not check was squish, and I actually did this last night, so I have it here, and I needed my bigger solder for this. So squish is at 25, 30, 31, 32, 32 and a half, 33, 34, somewhere around 33, 34 thousandths. That's where squish is at on this motor right now. Let's take the top end off. As far as the, no, you know what? Let's remove the clutch and all that other stuff. Let's get all that removed, and that way we can actually use the piston stop to do that. So we're going to remove this C-clip here. And then there's this washer. And there's this is a 3/8 7-pin rim. This should effectively come right out. Yucky, yucky. Don't forget this bearing. So we have a three padded clutch, which means I need to make a tool to actually get that off. Lovely. Just something else I gotta build. I don't know if I'll actually be able to get that off imminently. I just don't know. Need to make a tool for it, but I don't have the right socket, and I don't know if I'm willing to sacrifice one of my good ones. But I may have to do that. I wouldn't necessarily consider this a good one. Hey, that might actually work. KD. Do I use that one, or do I use the next size up? Maybe the next size up. One inch. That looks like it ought to work. So now I got to grind on this in order to make it fit down so I can actually remove the clutch properly. So I've just got a spare socket here that looks like a 1-inch socket. This happens to be a 12 fluted socket, but what I do is just grind off the sides here. So I'm going to get this as centered as possible. And then mark on the sides where I want my cuts. So I've got my cuts, and they don't need to be that deep, but just somewhere around I've marked X where I want the cut out. And I'm just going to take the angle grinder to this. And I'll have my own clutch removal tool. Which really seems kind of silly because I don't really plan on doing lots of these saws, but then again, don't really need this particular socket. I've got quite a few sockets in my possession, and always seem to be able to pick up stuff like this at a pawn shop if you really need it. So I'll grind on it and get back to you.